Welcome to the video on Aufbau. You've already learned that the electron cloud is broken down into energy levels, and the energy levels are broken down into subshells, and the subshells are broken down into orbitals, and the electrons are in those energy levels and subshells and orbitals. And you learned how to draw each of those energy levels and subshells and orbitals. But the next question is, how do I know which energy levels and which subshells am I be drawing for any particular atom? If I tell you to draw magnesium, how do you know what to draw? You can use your periodic table to tell you in the order in which the energy levels and the subshells go. First of all, and you should get out your periodic table at this point because you're going to draw some stuff on it. The periodic table is broken down into those 4 blocks for S, P, D, and F, and it goes as follows. All of the alkali metals and alkali earth metals are in the S block. So draw that on your periodic table. Draw a big box around your alkali metals and your alkali earth metals. Also, helium is in that spot. Just helium atom, not the rest of the noble gases. So all those are S block, and you can see where helium would kind of fit right there. And I'll explain what it means to be an S block element in just a second, but let's get the rest of them done. All of the nonmetals over here, this big box here, so the nonmetals and the transition metals that go under the stairs, and all the noble gases except for helium, these are in the P block. So draw that on your periodic table, draw a big box around that square, and call that the P block. All of the transition metals, from scandium to zinc, are in the D block. And then all of the inner transition metals are in the F block, like so. So break your periodic table down into those blocks. Now you're going to have to remember where those blocks are because on the test you get that empty periodic table as you did before. But it's pretty easy, there's only 4 blocks. So these blocks represent the shape of the subshell in which the last electron has been put. For beryllium, it has 4 electrons. Excuse me. And so its 4th electron will be in an S shape. For manganese, it has 25 electrons. That's 25th electron is going to be in a D shape. And it works like this. So the subshells belong in energy levels, and we already said the energy level is equal to the period number. So to find the subshell, you have to have a number and a letter. The number represents so you have a number and a letter like this, say 4P, just as for example. So the number is going to be our energy level, and the P is going to represent our subshell. Okay, how do I know where that is? Well, we're talking energy level 4, so we're in period 4, and we're in the P block, so we're over here. Somewhere between gallium and krypton are the 4P elements. So you read the list of the periodic table, the periods, and you put it with the letter of the block. Now, there's a catch. If you're doing S and P, then the period number equals the energy level. For D blocks, however, there is a kind of a hitch. Then the energy level equals the period number minus 1. Why are we subtracting 1 for the D blocks? Remember from the first video, I told you that the first energy level has 1 subshell, and that subshell would be S. The second energy level has 2 subshells, so that would be S and P. The third energy level has 3 subshells, S and P and D. Well, let's look on our periodic table. Period 1 has 1 subshell, S. Both hydrogen and helium are in S. Period 2 has 2 subshells, S and P, so we're good. But when we hit energy level 3, we know that we're supposed to be S, P, and D. However, period 3 does not have S, P, and D. Period 3 only has S and P. So therefore, to make the energy level have a D, we have to borrow this row of D from period 4. So even though this is period 4, this is actually 3D. From scandium to zinc, they're at 3D. So in order to say what is this D, we have to subtract 1 from the period number in order to figure out the energy level number to go with our subshell D. For F, the energy level equals the period number minus 2. For the same reason, we know that the fourth energy level has 4 subshells, S, P, D, and F. But when we go down to here, we have an S, we have a D, that's not this one because that's 3D, so that means we have to go down here. So we go to 4D here. We have a P, here's 4P, but we don't have an F. The F's are down here. These guys fit in the periodic table right here. So they don't start until the 6th period. So therefore, if these are in the 6th period, but they have to be in energy level 4, we have to subtract 2 from the period number to get to the energy level. So these, from cerium to lutetium, these are 4F. So let's just recap. 1S, 2S, 3S, 4S, 5S, 6S, 7S. No big deal. There is no 1P, so we have 2P, 3P, 4P, 5P, 6P. It matches up with these numbers over here. For the D's, you have to subtract 1. So this is in period 4, so it's 3D. This is in period 5, so it's 4D. So this would be 5D, and this would be 6D. For the F's, this is period 6, again, because it fits up here, and this is period 7. But we have to subtract 2 so that we get the right number of subshells in 4 and the right number of subshells in 5. So even though this is period 6, this is 4F, this is period 7, so this would be 5F. So all of the elements are in an energy level and a subshell, and that energy level subshell indicates the position of, or what contains their last electron. So manganese, we said before, its 25th electron is in D, it's in 3D. And for gallium, its 31st electron is in 4P, and so on and so forth. So you can figure out all of the energy levels and subshells in any atom by knowing where they fit on the periodic table and knowing the periodic table breaks into these 4 blocks. And then just remember that for D, you have to subtract 1 from the period number, and for F, you have to subtract 2. Thank you.